Hello everyone, my name is Shahriyar Irshad and I'm going to present my final project presentation for ADTA 5130. I hope you all like it and surely learn something from it. Um, so let's start. These days, almost every field is being impacted by data analytics, although I believe it's still in its very early stages because many people are reluctant as they do not necessarily have all the insights about the advantages that it can provide to their businesses. However, our focus today will be on the real estate industry. uh, I believe the real estate industry can greatly benefit from data analytics. Uh, However, the availability of useful data, which can provide any meaning to us, is a very expensive pursuit, specifically in terms of the real estate industry. The reason I believe is simple because uh, if you think about it, the number of real estate transactions are very less as compared to other industries. Let's say, for example, automobile industry. You know, so people frequently change cars, then they basically change houses or buy new houses. Furthermore, a single house could have been sold multiple times, which gives different representations of the same property, which can be really, confusing at times. So I'm going to talk about my data set here a bit. So the data set was acquired from Kaggle, first of all, and it is provided from by the Kings County uh, in Washington. It's actually an official data provided by them, so that's why we can be sure about the authenticity of the data set. In total, the dataset had 21 variables and 21,613 records in it, which is a sufficient amount for us to do our analysis. I'd like to quickly discuss these variables and tell you what they mean. So the first one is ID, which is a unique ID assigned by Kings County for each of their houses. The date is the date of the home sale. The price is price of each home sold. Bedrooms is self-explanatory. It's number of bedrooms, so is number of bathrooms in the house. Square feet living it's the square footage of the interior living space. Square foot lot, it's the total square footage of the lot. Floors is the number of floors. Waterfront is a dummy variable, basically, which tells whether the apartment was overlooking the waterfront or not. uh, the next one is view, which is basically a value between 0 to 4, which rates how good the view of the property was. Then comes the condition variable, which is on a scale from 1 to 5, which tells the condition of the house. Then there's the grade variable, which has a value between 1 to 13, which basically represents how good the construction style of the house is. Square foot above is the square footage of the interior housing space, which is basically above ground level. Square footage basement is the interior housing space, which is below ground level. Uh, and then year built was when the house was built. Year renovated was the last time the house was renovated. Zip code was the zip code of the house. Latitude and longitude were the coordinates for location coordinates for the house. And then square foot living 15 and square foot lot 15 are basically the average of square footage of uh, the nearest 15 neighbors, basically. So that's about it for the data. Now, I'd like to talk about the problem statement here. The purpose of this analysis is to accurately predict prices for houses in Kings County, Washington area, based on the previous data we have, of course. And we'd like to look into the impact of different variables. whether changing some variables, how do they affect the price value? Does increasing the number of bedrooms increase the price of the house, or whether existence of a basement in the house significantly impact a change in the price of the house? These are some questions we are going to address in this analysis. The first and foremost, I think the most important part before we begin the analysis would be the pre-processing of the data set, which includes two main branches, according to me. Looking for any unusual values in the data set and transforming or creating new variables in terms of providing more meaning to our analysis. So it is very important to do this iteration. And in this data set, there's a variable year renovated and square foot basement. So both of these can have zero values, because year renovated is only has some value if the house was renovated. And similarly, square foot basement will have some value if the house has a basement. Otherwise, they will have zero values. So to make it simple, I transformed both of these variables into two new variables, which have values basically 0 or 1, representing whether a house has a basement or not, and whether a house was renovated or not. I hope that makes sense. Apart from that, the variables, the two new variables were created: year sold and month sold. These were created from the date variable, which is basically the date when the house was sold. However, looking into this further, this data set contains records from houses sold in 2014 and 15 only. And for the purpose of our analysis, I don't think these variables were of much importance. So these variables were taken out. Another variable, age, was created. It was calculated. Remember, we have the year built, when was the house built, so we could easily calculate the age of the house from that value. Apart from that, there were 13 records with 0 values in bedrooms and 10 records with 0 values in bathrooms. So these records were taken out. And apart from that, there was one house with 33 bedrooms, and it's really unusual for a house to have 33 bedrooms. So I assumed that it's probably an error, and that record was removed also. Apart from that, there's one more thing I'd like to mention. We had this zip code variable here. It was treated as a categorical value, and it was label encoded for the reason because so that zip code is not treated as an integer value basically. And for example, 95378 could be treated with higher priority than basically 95767. Moving forward, I'd like to show you guys the variables that were included in my regression model. So first of all, I'd like to mention the strategy I'm going to be using to predict the prices. Different linear regression models were created and with different variables. And at the end, these were the variables which seemed to provide the best outcome. So they were included in the model. As you can see, bedrooms, bathrooms, square foot living. The ones which were not included, I'd like to note those. The first one was the ID variable, which doesn't really give us any meaning. The second one was the date of the house sold. then the waterfront and view variables did not have much impact on the outcomes. The latitude and longitude also did not seem to be affecting the outcomes much. And apart from that, the years sold and months sold, since I told earlier, do not really fill the purpose of our analysis. So those were removed too. I'd like to mention the strongest relationships I found out during my analysis with the price variable, and and both of these are pretty much understandable and common sense as well. So the first one was the grade variable, which tells how good the house was, uh, how good the style of the house was, how good it was constructed, or how good the design was. And we can see here clearly that as that value increases, the price of the house is like most of the houses are of higher prices in those grade values. Similarly, if we see square footage, so it is pretty understandable that the bigger the house, the higher the price is usually. And so we can see in this diagram here, as the square footage is increasing, mostly the price is going up, towards the up. So this shows a very strong positive correlation here. I made up some records and predicted the prices of the houses using my regression model. So the first record had 3 bedrooms, 3 bathrooms, 1,800 square feet of living, 3,100 square feet of lot. It had 2 floors. The condition was 3 out of 5. The grade was 12 out of 13. Square foot above was 1,000. Zip code was 98178. Square foot living within 15 neighbors. The average was 2,000, and square feet lot 15 was 3,200 square feet. The age of the house was 30. The house was renovated, and the basement, it had a basement basically. And the result here we got was like 1 million and around 100,000. The second record had 3 bedrooms, 4 bathrooms, 1,300 square feet of living, 3,000 square feet of lot, 2 floors. Condition was 4 out of 5. Grade was 12 out of 13. The square foot above was 1,000. Zip code was 98125. And the square foot living 15 is 14. And square foot lot 15 is 3,200. The age of the house was 27. And the house was never renovated, but it had a basement. So the price of the house was 988,000. So if we notice in both these records, the main big difference is the number of bathrooms and the square foot living area is the main difference, and and whether the house was renovated or not. We can clearly see the first house has a higher price, and we can see that these variables are specifically impacting the price of the house. Thank you so much. I hope you guys enjoyed it and liked it and probably learned something from it. Thank you.